Welcome back. Let us now go to our Windows server and install the other roles. And the second role that we'll install is the certificate authority. So go to manage, add roles and features, click on next. And then, as I said you before, that once we install the Active Directory, then the DNS Server installed by default. So I will check the Active Directory Certificate Service, and then the Active Directory Federation Service as well. We'll click on next, and then install. So once the installation will finish, then a yellow triangle here will appear that will ask us to continue the configuration of the DNS of the ADFS server and the certificate authority. So the first role I will start with is the certificate authority, because the ADFS use that role. So the installation finished, and we click on close. So as I said you, that both the Federation service and the Active Directory Certificate service ask us to continue or to configure the services. So I will start with the Active Directory Certificate service. I will click on next, and then choose the certificate authority. Click on next, and here there are standalone certificate authority and there is the enterprise certificate authority. As long as we are installing this role on the same server where our Active Directory reside, then we have to choose the enterprise certificate authority. Click on next, and there are two types here of certificate authority. There are route certificate authority and there are subordinate certificate authority. And in the PK hierarchy, the most recommended one is to use a route certificate authority that will be outside of your domain controller, and then use that route certificate authority to sign another subordinate certificate authority. So if you, for example, your subordinate certificate authority be compromised, then you can, for example, if your certificates that are issued by the subordinate certificate authority are compromised, then you can stop or delete the subordinate certificate authority, and your hacker will not be able to access to your route certificate authority. But in this lab, I will choose the route certificate authority. Click on create a new private key. Click on next. I will keep everything as a default. Click on next, and then configure that. So once the configuration finish, I will go to tools and go to certificate authority, and then I will expand this, and in the certificate template I will create a certificate authority for my ADFS server. So for that I will click on manage, and I will choose the computer, right click on that and duplicate template, and go to general and provide it with a name and call it ADFS template, and then I will click on publish certificate in Active Directory. I will go to the security, or before that let me go to subject name. I will choose the common name. So my certificate will use the common name as ADFS server dot my domain name. Then the request handling, I will allow private key to be exposed. Then I will go, the last part is choose security. Then I will add, we'll choose object types, and then I will choose computers, because I want the certificate to be issued to this computer, or this, I want to allow this computer where my Active Directory reside to be allowed to enroll this certificate. So I will check names. I have ADFS and then check name, and it will complete me my ADFS host name, and then choose this one and then give it full control. But in production environment, I don't recommend you to do that. As here in this lab, I just showing you the steps that you follow to achieve that. So in request handling, come back and security, then subject name, right, and then general. So everything you have set it, and click on OK. So once that's done, let me close that and come back here and right click and go to new, and then certificate template to issue. Then we'll issue my certificate template I have created, and then click on OK. So this certificate authority is listed with among the other certificate template as well. And then now the next step is go and try to create a certificate for my ADFS server. For that, I will click on run and then open the MMS service, right click or go to file and then add and remove snapping, go to certificates and then click on add, choose computer name, computer account. Make sure to choose that because we have used the computer certificate template, and click on finish and then click on OK. Expand that and go to personal, right click on that and go to all tasks and then request a new certificate. You can click on next, and then you have this certificate that we have created earlier, and then enroll. So if you do not allow this computer to auto enroll in this certificate, then this state or this step will not finish successfully, but will be an error that will be occurred because you have prevented this computer from auto enroll. But because you have enabled or you give full control to this computer to auto enroll, then that is why this step is finished successfully. Click on finish and we close that. Before going further, we have to create an ADFS server service within our Active Directory users, because we will use that ADFS service to complete the configuration of our ADFS management service. So we'll go to Active Directory user and computer, expand this and go to users, and then add a new user and give it ADFS SVC, and then for example give it this name, this last name, and then for user logon name I will provide the same name. Then I will provide the password for this user, confirm the password, click on next and finish. So the last step now is to configure the federation service. So click on next. Because we don't have a federation server farm before, so I will create a new one. We'll click on next, expand this, and this is the certificate that we have signed earlier, and this is this icon, this is the name that will be displayed once we will open an ADFS ADP initiated sign-on, and they will show you that. So ADFS service, click on next and then select user, then I would choose ADFS, check names, and then choose this one I have created earlier, click on OK and provide the password that you have set for this user. Click on next, keep this database as a default, click on next and wait for the review, and then click on next, and then configure that. So in the meantime, so to use browser on this server, I will install Chrome on it. So let me come here to this file. This file I will provide you with it in my GitHub account. So make sure to subscribe to my GitHub account, and then let me come here, scroll down, and you copy this and open. So this one is configured successfully. I will close that and open a PowerShell, and they will run it as an administrator and paste that code here. So now the Chrome will be installed on our Windows server. And next step, because we want to have a log or sign in page, and to have that, the sign in page that's provided by our ADFS server, you have to enable the property enable ADP initiated sign on page. If you do not enable it, then you will not be able to reach that page. So to enable it, open PowerShell, run as administrator, and then click on enter. Then this property will be enabled. So the Chrome extension is installed. If I go to the search bar and type Chrome, then the Google Chrome will be opened for me. So now if I check Google, yeah, it's reachable. Let me accept the policies, and here the URL to reach that sign-on page is ADFS server abdalitraining.com/edfs/ls/adp initiated sign-on .spx. So as you can see, this one is opened, and now if I try to sign in, and they provide the ADFS user I have already created, training.com, and then provide the password as well. And then if I hit sign in, so you are signed in because the credentials are correct. So next step here is to open our DNS server. I will expand that and go to forward local hosted zone, and there is already a hosted zone here, and then I will create a record. But first let me copy the IP address of my Windows server. So let me go to instances and go to my Windows server, copy its private IP address, come here, sorry, I will choose my test instance and copy its IP address, and then create a new record. So I will call it test, and then IP address, and then add that record. So that record is added here, and now what I have to do is go to my other account and create a Route 53 outbound endpoint. And what this outbound endpoint will do, so every time from this instance we will ping to this instance using its record DNS name, then that DNS query will go to the Route 53 resolver, and after that it will go to the outbound endpoint, and it will find that to reach that record or to this domain, you will have to take an IP address that we specify in the role of our outbound endpoint. So when we will try to do hands-on, you will understand well. So let me go to the hands-on and go to the Route 53. So in this Route 53, I will create an outbound endpoint. And let me go scroll down here and go to the outbound endpoint. And this outbound endpoint, I will provide it with some configuration. So I will configure endpoint. I will choose North Virginia, outbound only. Click on next. We'll call it my outbound endpoint. So what is the VPC that my DNS query will flow from? And it is the North Virginia. And for security group, I have no security group. I have to create one. So let me go to my instances and create a security group. And this security group will allow all the traffic, all the inbound traffic on TCP and UDP port. So scroll down and go to security group. So I'll create a security group. I call it my outbound security group. I will copy that and paste it here, and I will choose my VPC. And then for the inbound roles, I will choose all TCP and then all UDP, and then I will scroll down and then create that security group. I will come back and try to refresh, and then I will choose my outbound security group. I will scroll down here, and then for the availability zone, I will create one as. So what are these IP addresses? These IP addresses, once I choose them, then the AWS Route 53 resolver will create ENIs in these different availability zone and in different subnets. So I will choose only public subnets. We'll scroll down. I will choose this one as well, same subnet, but for high availability you must have different subnets. Click on next, call it my role. I will scroll down, and then for the domain name I will call it, this is the domain name that I have within my DNS, and then choose the VPC. Sorry, here I have to edit that. So this is the DNS name of our domain that reside in the second AWS account. I will choose my VPC. I will scroll down, and for the target IP address, I will choose the IP address of our Windows server. So let me go to our instances and choose my private DNS, the IP address of our DNS server. So let me come back to my AWS Route 53 resolver and paste it here. I will scroll up to make sure that I have set everything properly. so to do not face issues in the future. We'll click on next, review that, and submit. So we'll wait my outbound point to be created, and in the same time let me go step further. So here, to say to this instance that when, or to say to our DNS server that when you receive a DNS queries that belong to this domain, what you have to do. And for that we have to create something called conditional forwards in our DNS server. But before we create that, we have to create our inbound point, because this inbound point endpoint, once we will create them as well, they will create IP addresses or ENIs within our VPCs, our subnets. So now let us come back to our AWS Route53 resolver and create our endpoint. Inbound endpoint, my inbound endpoint. And for the VPC, I will choose a VPC. For security group, I will choose the same as the previous one. And for the availability zone, I will choose my one subnet, and then create inbound endpoint. So here our outbound endpoint is created successfully. If we now try to go and connect to our instance and try to ping test planettraining.com, as you can see that the ping works successfully, right? Because as you end the response, you see 10.1.117. And if we come back here to our server, Windows server, and come back here, it is the IP address of our test machine. And if we come back here and go to our DNS record, here as you can see the test, it is 10.10.10.117. And the same thing we are doing now is that we want to ping from this instance to other instance using its domain name rather than its IP address. And we will see whether if our Route53 resolver will resolve that DNS record name. So, but first we have to wait until the inbound endpoint created, so we'll be able to take its IP address and provide it to our DNS conditional forward. So let me come back here to our inbound endpoint, and now it's created successfully. Let me expand that, and here it will provide me, it's provided me with public IP addresses. Sorry, it provided me with the private IP addresses. So we have to make note of these IP addresses because we'll use them later on. But first thing, before go further, we have to come back to our instance that reside within our VPC, that is within our second account, and go to etc resolve.conf. And here, that in the DNS resolver, we have this name server and this DNS name search. So that's obvious that this instance will try to, when it will try to ping to this instance, it will use these records. And we have said that we will add a conditional forwards to the DNS server. So once the DNS query will reach to this DNS server, then it will know to which DNS server it should to forward. But the problem here is this DNS, is this instance in its own DNS configuration, it does not know anything about this DNS, right? DNS name. So how we will say to this instance, once it will try to send DNS query, it must to forward them to this DNS server, and then the DNS server itself will forward that traffic to this inbound endpoint, and this inbound endpoint will send it to the Amazon 53 resolver. Then this DNS resolver will send it to Amazon private hosted zone. Then this private hosted zone will know that records it is for this instance. Then this instance will respond to this instance ping. So for that, we have to set something else. Let me come to my instances here, or to my account, or my second account, and try to add something. And here we will create the DHCP option sets. And this DHCP option set is just a configuration. It's like your corporate data center DHCP server. So what is the responsibility of DHCP server? Is once an instance try to connect to the internet, or to connect to the your router, it will provide, the DHCP will provide that instance with an IP address, and it will provide as well with the configuration that we found here in the etcresolve.conf. It provides the name server, IP address, and the search for the domain, right? So this, what means this search? So for example, this search, rather than type, for example, x dot all the entire domain name, you just need to provide the x, and then your host will go to this configuration and then try to bind that x with this domain, and then it will forward the DNS query to x.us3.compute.internal. I think you got the idea. But now this host does not know anything about this DNS name or this DNS server IP address. So for that, we have to create a DHCP option sets, and then change the default DHCP option to my VPC. So my instance, rather than have this DNS name server and this one, it will have the DNS server IP address of our Windows server, and this domain name. So for that, let me go to my VPC DHCP option set and create DHCP option set. So I will call it my DHCP, and for the domain name, I will provide my domain name, and then for the IP address, let me come back here and then take the IP address of my private address of my Windows server DNS, and provide this here. I will scroll down and then create the DHCP option sets. Then come back to my VPC, choose my VPC, or click on it and go actions, and then edit the DHCP option sets, and then choose my DHCP and click on save, and make sure to edit the hostname sets, enable it, and also DNS resolution as well. But even if you change the DHCP option set of your VPC, that DHCP option set will not be detected automatically by your instance. Rather than you must reboot them. So this is our OpenSwan instance. So let me go to IPsec. So as I said, so to make this instance detect the new changes on the DHCP option set, we have to reboot them. So before reboot this OpenSwan instance, make sure to enable the IPsec service. So once that service or once that instance rebooted, that instance will start automatically rather than wait us to start it manually. So for that, we will try to enable it. So now I will come back here to my instances and reboot all of them. And another thing here is that already when we tried to set up the VPN connection between our two AWS accounts, the ping have worked even we have not enabled the change source destination check, even we have not enabled the stop source destination check. And that's because I thought that this instance, it is the test instance. That is why that connection established. But if, for example, if you try to ping directly from your OpenSwan, even if you do not disable the source destination check, it will work. But if you try to ping from your test instance, it will not work until you enable the source destination check. And also you must to enable the security group of your OpenSwan to allow the ICMP protocol or the ping. If, for example, you does not open that port on your OpenSwan, then that OpenSwan will not allow the traffic to flow throughout your VPN site-to-site connection. And another thing else is that you have also, as I showed you before, is that you have to add that instance to your route table. Here you have to add this. It's mandatory to add this instance to your route table. Otherwise, it will not work. So let me come back to my instance, to my Windows server. Try to connect to it. Connect. And then Paris. And then decrypt the password. We'll scroll down and copy that password and paste it here. And for other instances, let me connect to my OpenSwan. Sorry, my OpenSwan again, and then to my test instance as well. So let me come back here, try to close that, open another tab, then SSH C2 user, yes. So if I come back to my test instance, and copy its address, try to ping. So the ping work from the test instance. Another thing here, if I come back to my OpenSwan and try to switch to root and then go to nano etc resolve.conf, as you can see here that the IP address changed and this line added as well. So now if I get to my AWS Route53 and then go to my hosted zone, scroll down and create a record for my instance. So we're gonna call it test, it's an alias, and then for the instance I will copy its address and then I will create that record. And now let me create our conditional forward in our DNS server. So go to server manager, go to tools and then click on DNS, expand that, and in conditional forward right click on that and choose new conditional forward, and for the DNS domain name I will choose ablali.com, and then for the IP address I will choose the first one and the second one as well. So even if you have an error here that there is an error of unable to resolve, it's okay, and then click on OK. And then now let me come back to my instances that reside within my second account and try to type ping test dot ablali.com. And it is obvious that the ping will keep hang on. Why? Because I must to go to my OpenSwan security group and enable the port 53 on TCP and UDP, and it is the port of the DNS. So for example, if you want to forward some request from your from this resource that reside in the second account to other resource on other account, you must to enable the same port that you will enable it on this instance to enable it on the open one. So go to security group, scroll down, edit inbound roles, DNS, UDP, everywhere, anywhere, DNS, TCP, anywhere, scroll down and save roles. If we come back now and try to ping, then the ping this time is hang on. Let me come back to my instance. Here, scroll down and go to security tab and go to the security group, scroll down, it is allowing the ping. Let me come back to the instance and make sure that I have copied its IP address successfully. Scroll down. Yes, I have done it. That. Let me come back to our DNS server. Check here, try to ping test com to work. Wait, let me service IPsec status. So it is starting successfully. So let me ping test at .com. And if, for example, if I come to CMD, this way you can troubleshoot what's going on, what is the problem that prevent that from pinging. It is hang on, so maybe there is a problem in security group that we have to check it. And The first thing you have to check is your route table. So let me go to my route table. And let me go to my instances and try to connect to my instance as well. So open another tab and cd to documents AWS, and then try to SSH to my instance, and then try to ping test.com. Yes, so this ping is hanged as well. So let me come back to my